sorting in the collection API. In order to sort elements in the collection API, all elements should be same type. If every element is the same type, then only you can compare one element with other element. If there are 10 elements strings, one element is an integer, how that integer element can be compared with the strings? Assume 10 elements are person objects, one element is a product object. That product object cannot be compared with other person objects. That is why wherever sorting you are trying to perform, every element should be same type. If all elements are same type, then only sorting is possible. First condition, all elements should be same type in order to sort. Second condition, no element can be a null. If any element is a null, you will be getting a null pointer exception. If any element is a null, you will be getting a null pointer exception. First condition, all elements should be same type. Second condition, no element is a null. Third condition, all elements should be comparable type. Otherwise, either comparable type or you need to supply a separate comparator object. Today we will focus more on comparable and a comparator. So sorting is very important. We are just going through all basic operations in the collection API. So we have already seen how to add, how to insert, how to remove, replace. A lot of basic operations we have seen. We just started sorting. In order to perform a sorting, every element should be same type. Second one, no element can be a null. Third one, all elements should be either comparable type or separate comparator object should be supplied. Let us see here. Import array list 1, new array list. It is a simple array list. We already understood all elements should be same type. We already understood no element can be a null. All elements should be same type, no element can be a null. List1 dot add. Let me go for all integer elements. All integer elements. This is one array list. Try printing content of this array list. List1. Try printing list1 once again after sorting. It is completely straightforward. There is no difficulty to understand this. All elements are same type. No element is a null. No element is a null. Third one, every element should be comparable or separate comparator should supply. We are not supplying separate comparator. Now, all these elements are comparable type. In the previous sessions, I told very clearly, collection API not allowing primitives. Collection API allowing objects. By any chance, if you are supplying a primitives, that primitives are boxing into objects. So here 10 is boxing into integer object 10. 110 is boxing into integer object 110. 510 is boxing into integer object 510. 105 integer object 105. 1 is boxing into integer object. That integer class is a subclass to comparable. All wrapper classes are implementing comparable interface. Every wrapper class implementing comparable interface. All the wrapper classes. It can be byte class, it can be integer class, it can be long class, it can be double class. Every wrapper class implementing comparable interface. That is why all these are comparable type. Sorting is very successful. Similar to list 1. Let me go for one more list. List 2. In the list 2, try providing all double type of elements. All are double. All are double. Definitely sorting will be very successful. First condition is all are double. No null. Second condition is no null. Third condition, all should be comparable type. Every wrapper class is a comparable type. This also very success. Please check it out. List 2 also running very successfully. Let us run. So please observe every wrapper class implementing comparable. We had to follow 3 conditions. First condition, all elements should be same type. Second condition, no element is a null. Third condition, all elements should be comparable type. Otherwise, a separate comparator object has to supply. A separate comparator object has to supply. We are providing all double objects. Double class is already implementing comparable. Double class already implementing comparable. Double class already implementing comparable. Understood? So that is why list 2 also sorting very success. Let's go for list 3 in the same program. In the list 3, I'll go for string objects. Guys, This also running very successfully. Please observe. String class also implementing comparable. String also implementing comparable. Everybody, string also implementing comparable. All objects are one type, those are string type, no null, no null. String class also implementing comparable. You can just check it out whether string is implementing comparable or not. You can browse the API from the internet just to type java.lang.string. Type java.lang.string. You will be getting a first link itself from the Oracle. Java.lang.string, first link itself. Click on the first link. All implemented interfaces, are you finding comparable? Everybody, are you finding comparable? See, comparable implemented by these many classes in Java. See, if you wanted, you can check for the wrapper classes also. So go to the Google, go to java.lang.integer. Click on the first link itself. Implements a comparable. Every wrapper class implementing comparable. String class also implementing comparable. Come to the next one. Let me go for list 4. I'm supplying this time string buffer. For the list 4, I'm supplying 2 string buffer objects. String buffer also implemented comparable type interface. Just to open string buffer, everybody, java.lang.string buffer. Serializable char sequence. Let me go to the char sequence. So just check it out. In the latest version of string buffer, it is implementing comparable interface. So earlier we were browsing JDK 1.8. So download latest version of JDK document. Let me show how you can download the documentation. Please follow me, everybody. Downloading the documentation. Please go to oracle.com. Go to products. Go to oracle.com. Go to the products. Click on Java. Click on download. Under download, come to the bottom. There is a download documentation. You can see documentation download. Documentation download. Click on documentation download. Select this zip file, download, extract. There is a zip file, download it. After downloading, extract. Everybody. This is the zip file, extract it. After downloading, extract it. Go inside extracted folder, docs folder, API, Java base module. Go inside a Java base module. In the base module only, several classes available. All wrapper classes, string class, string buffer, string builder available in the Java base. Go inside. So click on module summary. Under module summary, you can go to the java.lang package. Click on java.lang package. Under java.lang package, come little down. You can find a string buffer. String buffer class. Click on this string buffer. This is the latest version of string buffer. You can see implements a comparable. String buffer also implementing comparable. So please observe all wrapper classes, string class, string buffer class, string class, string buffer class, even string builder class also having same properties. Let's go for string builder. This time we are using string builder. Try developing a list of 5 with a string builder. So for example purpose, let's go for array list with the elements of other than everybody, other than comparable type. I'll just develop one local inner class here. Everybody, let's go for local inner class. I'll go for an object of local inner class. Now my class A is not a subclass 2. Now my class A is not a subclass 2. Subclass 2. Comparable. It is not a type of comparable. Class A is not a type of comparable. You can see whether class A objects we can able to sort or not. Class A objects we are not able to sort, we are getting class cast exception. So please observe, sorting is very important. Here we are following first condition, all elements are A type. We are also following second condition, no null element. But we are not following third condition. A is not a type of comparable, and even we are not supplying a separate comparator object. A is not a type of comparable. We are also not supplying a separate comparator object. So third condition is failing. That is why we are getting an exception. So before learning more about this third condition, let us start storing derived type of objects in the collection API. Let us see what are the minimum requirements while storing derived type of objects. Then we will go for conditions of comparable separate comparator. Everybody, let's start a new M30. So all you know very well about inner classes. I always prefer inner classes. Why? Because same name can be chosen in across the different driver classes. three class A objects. Class A objects stored in the array list. Class A objects stored in the array list. Class A objects stored in the array list. We are printing array list. You are not getting I values. You are not getting I values. You are getting class name at the rate hexadecimal representation. Please observe this. So please observe. While printing array list, internally, it is calling toString method inside a array list. The toString method of array list calling toString method on class A. What is this toString method? Everybody. What is the toString method? In the object class, there is a toString method that is inherited to class A, also inherited to array list, available in every class. The toString method calling whenever you are printing a reference variable, array list toString method, come on. Whenever you are printing a reference variable, it is calling toString method. Inside array list toString method, it is calling toString method on every member. I repeat once again, everybody. Whenever you are printing a reference variable, internally, it is calling toString method on the reference variable. It is calling toString method in the array list. That toString method of array list, it is calling toString method on every member. toString method, object class method. It is available in the class A. It is also available in the array list. Whenever you are printing a reference of object, everybody, whenever you are printing a reference of the object, internally it calls a toString method. It is calling array list toString method. Array list toString method internally calling toString method on every member, on every element, on every A1, A2, A3. Inside a class A, we did not override toString method of the object class. It is providing default message, that is class name at the rate hexadecimal representation of memory address. Memory address you are getting, you are not getting content of object like I value 10, I value 5, I value 4. I repeat once again, please observe everybody. First and foremost point, please observe. First point, crystal clear. First point, while printing a reference variable, while printing a reference variable, internally it is calling toString method. While printing a reference variable, internally calling toString method. While printing a reference variable, internally calling toString method. Whenever you print a reference variable, it calls a toString method. Whenever you print a reference variable, it calls a toString method. What is the toString method? Second point. What is the toString method? Second point, what is the toString method? toString method is nothing but An object class method. ToString method is a one of the method in the object class. A ToString method is nothing but a member of the object class. Inside an object class, several methods are there. Among them, ToString also one. You can just check it out in the API of object class or through Java P command. Let us check it out. API of object class. Go to java.lang package. You can see object class. Inside an object class, there is a ToString method. Inside an object class, there is a ToString method. You can see here, ToString. Object class containing ToString method. This is the ToString method in the object class. Crystal clear, everybody. First point, whenever you are printing a reference variable, internally it is calling ToString method. Whenever you are printing a reference variable, internally calling ToString method. Second point, what is this ToString method? It is a method in the object class, inherited to every class. It is available in all the classes. It is available in all the classes. Let's move to the third one. The third point. What is happening inside a ToString method of array list? What is happening inside a ToString method of array list? ToString method of array list, everybody. ToString method of array list, it is calling ToString method from every member. It is calling ToString method from every member. It is calling ToString method from every member. From every member. On A1 it is calling ToString method. On A2 it is calling ToString method. On A3 it is calling ToString method. Understanding? So A1, class A. Inside a class A, ToString method, it is an object class ToString method. We did not override. We did not override. It is an object class ToString method. If it is an object class ToString method, it is providing a default output, that is class name hexadecimal representation. Class name hexadecimal representation. Hexadecimal representation of memory address. I repeat all the points once again. Please observe, everybody. Whenever you print any reference variable, internally it calls a ToString method. Internally it calls a ToString method. What is a ToString method? It is a method in the object class, inherited to every class. It is available in the array list. It is also available in the class A. It is also available in the class thread. In every class it is available. Third point. In the array list, whatever ToString is there, what the ToString is doing. Inside array list, whatever ToString is there, that ToString method, it is calling ToString method from every element. 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 Understood? Now what are the elements in the array list? A1, A2, A3. What are these? These three are references to class A. Three are pointing to objects of class A. Inside a class A, toString method is not modified. It is a object class toString method. It is a object class toString method. What object class toString method is doing? It is having a default output. The default output is printing class name and hexadecimal representation of memory location. Hexadecimal representation of memory location. This point is very important. So that is why we are getting output as class name @ hexadecimal representation. This is the whole class name. It is an inner class inside a M30. Inner classes will be with a dollar class name. Where it is an inner class inside a M30. Where that M30 is available? Where that M30 is available inside a app1 package. Now everybody, copy class A and main method. Copy class A and main method. Let's define M31. Place inside M31 and remove the import. One import will be getting. Say earlier I was having this type of import. Whenever you are copying, copy and paste from the previous Java file. So previous Java file class A will be importing. Just to remove this. Now what I'll do is, I'll try to override class A toString method. Everybody, I don't want object class toString method in the class A. Let us override object class toString method. Whenever you are overriding, the habitual of control space bar. Don't try to type the whole method name. You can say toString method, control space bar. Are you finding toString method? Type T. You'll get a toString. Select it. I don't want object class toString method. I don't want object class toString method. I don't want object class toString method. Remove this. I'll return I is equal to value of I. I'm trying to print content of object rather than address of the object. Content I is equal to value of I. The current object content. The current object content. Class A toString method got overridden. Class A toString method got overridden. Class A toString method got overridden. Now, I'm not changing anything in the main method. Try running. You will be getting a different output now. You are not getting memory address. You are getting the content of the objects. You need to understand importance of toString method with respect to collection objects while storing objects. While storing derived objects. Done, everybody? I repeat all the points once again. Everybody please observe. Whenever you print any reference variable, internally it calls a toString method. The toString method is a object class toString method. The toString method is a object class toString method. In every class, the toString method available. In the array list also, the toString method available. But in the array list, the toString method got overridden. They are calling toString method on every element of array list. Inside array list, toString method got overridden. Like in our class here, we have overridden. Likewise, in every collection API, toString method got overridden. In the body of the toString method, they are calling toString method from every element of the array list. What are the elements? A1 is one element, A2 is another element, A3. So they are calling A1.toString, A2.toString, A3.toString. What we are doing in the class A? We override toString method. We have overridden toString method in the class A. We overridden toString method in the class A. What we are doing? We are printing I value rather than memory address. Rather than memory address, we are printing I value. This is very, very important. Now everybody develop another class with two attributes. Try providing all this information. Take 5 minutes time. Develop another like a M32 static inner class A with two attributes. Static inner class A with two attributes. Check it out how you can able to do. I'm copying class A, main method. I want to keep one more attribute, int j. Try printing both I and j. I is equal to something. So for every object of A, provide j value also, some j value, any j value. multiple attributes. Class A object containing we are printing A1, A2, A3. A1 object containing ij, A2 object also containing I and j, A3 object also containing I and j. Try running. This is how we will be overriding toString method in the derived objects. So totally 3 objects we stored in the array list. Every object containing 2 attributes. Both attributes we are printing in the toString method. I'll maintain this as a much more simpler. Copy the same. Go for 33. Use the constructor to assign. Remove the import. Inside a class here. Try providing argument constructor. Two parameters constructor. Two parameters constructor. Now try supplying a values while creating an object itself. We don't need these two assignments. Making simplicity. Please check it out. We understood how we can print content of array list if it is containing derived objects like a class A. So please observe whatever we are doing in the toString method of class A. Everybody, whatever we are doing in the toString method of class A, same is doing in the string class, string buffer class, string builder class, and in all wrapper classes. In every wrapper class, toString is overridden, printing the content of wrapper object. Inside a string class, toString is overridden like this, it is printing content of the string object. Even in the string buffer also, toString method got overridden, printing content of the string buffer object. In the string builder also, toString method got overridden, printing content of the string builder object. Everybody, in all wrapper classes, toString method overridden, printing the content like a class A. Inside a string class, toString method overridden, printing the content like in the class A. String builder, string buffer also, toString method got overridden, printing the content. Now, come to the next example. Let us understand sorting in the class A. I'll go for static class A. Only one attribute I am keeping. Same attribute initializing through constructor. Override toString method. Come to the main method. I'm creating an object directly in the add statement. Go for try running. You are getting runtime exception. First two conditions we are following. All elements are class A objects. Second condition, no element is a null. Third condition we are not following. What is the third condition? Whether all elements should be comparable type or separate comparator object should be supplied. So we are not following third condition. That is why we are getting runtime exception. So copy class A and main method. Copy class A and main method. Class A and main method. Whatever import we are getting, remove this. Let us modify class A. Implements. Implements comparable. implements comparable. Comparable is a interface available in the java.lang package. It is a part of java.lang package, no need of importing. It's an interface. Remove the angle bracket while importing. Sorry, no need of importing, but if you press Ctrl space bar, you'll get a angle brackets. Just to remove that. It is a functional interface. You know what is a functional interface? An interface which contains only one method. An interface which is containing only one method. That is functional interface. Functional interface. It is containing only one method. Let us override same abstract method with the implementation. Again go for Control space bar. Through Control space bar, select abstract method of comparable. Abstract method of comparable. This is the abstract method of comparable interface. Abstract method of comparable interface. Abstract method of comparable interface. What we have to do is comparison between the objects based on I value. Comparison between the objects based on I value. Go for I minus. Converting argument O into A type. Converting argument O into A type. Converting argument O into A type. Compare to method. Compare to method. It is a part of the comparable interface. Implementing the same method for comparison purpose. Framework using internally this method. In order to compare first object with second object, internally it is using compare to method. In case of comparison, definitely you require a difference. So if difference is a bigger one, then definitely first one is a bigger. If difference is a negative value, then second one is a bigger. Let us consider there are two people, A and B, two persons, A and B. A's age is a 30, B's age is a 25. 30 minus 25, it is a 5. So A is a bigger. Let us consider A's age is 25, B's age is a 30. A age minus B age, that is minus 5. So A is a smaller than B. Whether it is a positive or negative, through a difference, we can easily identify whether first one is a bigger or second one is a bigger. For comparison purpose, framework internally using compare to method. For comparison purpose, framework internally using compare to method. Now try running. You will not be getting an exception now. All three conditions we provided. No element is a null. Second condition. All elements are same type. First condition. all elements are comparable type, third condition. Sorting is very proper. Observe everybody. Framework internally using compare to method in order to compare first element with the second element, which is bigger, whether first one is a bigger or second one is a bigger. For that purpose, internally using compare to method, it is like first object dot compare to of second object. If it is getting a positive number, first object is a bigger. If it is getting a negative number, second object is a bigger. Sorting is nothing but comparisons. It has to identify the order based on a particular value. That value is I value. Same we mentioned in the compare to method. We are not calling compare to method. Sort method internally calling compare to method in order to identify which object is bigger, which object is smaller. It is keep calling on multiple objects to identify which is bigger, which is smaller. Taking first two elements, calling compare to on first element by supplying a second element. Then taking third and fourth element, on third element calling compare to by supplying a fourth element. Likewise, if you wanted, you can keep an SOP in the compare to method to check whether this method is calling or not. Try running. Framework internally using compare to method in order to identify which is bigger, which is smaller. We never called compare to method in the main method, but you can see several times compare to method is called. Framework internally calling compare to method to identify which is bigger, which is smaller. Understood? Compare to method. If it is single attribute, compare to method from the comparable, highly sufficient. So please practice all these points. I'll continue in the next session. Definitely, these points more and more practice is required. Practice all these points. We'll continue in the next session.